Hello, everyone, and welcome. We'll get started in just a minute. I'll give everyone a little bit of time to get settled in, and then we can go ahead and get this webinar going. All right, let's go ahead and get started. Hello, everyone. On behalf of the Environmental Finance Center Network, welcome to our webinar on asset management for wastewater systems. My name is Kristen Crew from the Syracuse University Environmental Finance Center. Before we begin, we're going to go over a few logistics and then we can get started. During the webinar today, everyone will be kept on mute to ensure audio quality. If you have a question, please type it into the GoToWebinar question dialog box anytime throughout the session. We will be saving your questions for a facilitated Q&A session at the end of the presentation. You will receive a follow-up email that includes a link to the recording and other information that you may need. You can also download the slides from today in the Handouts tab in your GoToWebinar control panel. This webinar has not been submitted for pre-approval of continuing education credits, but eligible attendees will receive a certificate of attendance for their personal record. To receive a certificate for this session, you must attend for the entire session and register and attend individually using your real name and unique email address. Certificates will be sent via email within 30 days of the webinar date. If you have questions or if you need assistance, please contact smallsystems@syr.edu. Now for a little bit about us. The Environmental Finance Center Network provides training and technical assistance to small water and wastewater systems in all U.S. states and territories through our building technical, managerial, and finance capacity programs. If your community or utility needs assistance with drinking water or wastewater system management, please feel free to contact us through our request form, which I will be sharing shortly in the chat. And on that note, we can go ahead and get started. I would like to introduce our presenter for today, KT Newman. KT is the owner of Utility Contractors, LLC. Welcome, KT, and I will go ahead and hand it over to you.
Thank you, Christy. As stated, my name is KT Newman. I am the owner of Utility Contractors, and at Utility Contractors, we provide managerial and technical assistance to water and wastewater clients across the state of Mississippi. I am happy to be here with you today for our topic, asset management for wastewater utilities. I think we can all agree that this is an appropriate topic for the times in which we are currently living. Having said that, renewing and replacing the nation's public water infrastructure is an ongoing task. Asset management can help a utility maximize the value of its capital as well as its operation and maintenance dollars. Asset management provides utility managers.
KT?
Yes.
I can't see your screen yet.
What about now?
There it is. All right, great.
Okay, could you hear me?
Yes, I could hear you, just couldn't see your screen.
Okay. Asset management provides utility managers and decision makers with critical information on capital assets and timing of investments. Some key steps for asset management are making an inventory of critical assets, evaluating their condition and performance, and developing plans to maintain, repair, and replace assets and to fund these activities. This discussion on asset management can be applicable to any water and wastewater system and is intended to be a starting point on the basic elements of asset management. Furthermore, whether you're an operator, engineer, policymaker, or administrator, you play a vital role in the management of assets for your utility. Due to time constraints, we will not go into extreme depths on any of the topic areas relating to asset management. This discussion is structured more as a brief overview. Over time, however, systems will be able to improve their asset management programs and will be able to increase the sophistication of these programs. For systems that wish to have a more robust asset management program, there are many guides and resources that can help achieve a higher level program. In addition, systems with greater economic resources may wish to seek out consultants specializing in asset management to aid them in developing a more detailed asset management program. We're certainly in a time of unprecedented need as it relates to aging and crumbling water and wastewater infrastructure. Cost estimates for water and wastewater system needs across the country are in the tens, if not hundreds of billions of dollars. Existing state and federal funding sources can only meet a fraction of this need. These sources of funding are not expected to increase and in many cases are declining. Therefore, approaches to reducing the gap between what is needed and what funds are available will need to be adopted. In addition, funding agencies want assurance that the investments they make in water and wastewater infrastructure will be adequately managed and maintained to ensure long-term sustainability and security. This assurance will require water and wastewater systems to present convincing evidence that they possess adequate financial, technical, and managerial capacity to provide the service that their customers expect, to maintain the infrastructure necessary to provide that service, and to manage the organization technically and financially throughout the life expectancy of the improvements being financed. So what is asset management? Asset management is a process wastewater utilities can use to make sure that planned maintenance can be conducted and capital assets can be repaired, replaced, or upgraded on time, and that there is enough money to pay for it. Asset management is the practice of managing infrastructure capital assets to minimize the total cost of owning and operating these assets while delivering the desired service levels. Many utilities use asset management to pursue and achieve sustainable infrastructure. A high-performing asset management program includes detailed asset inventories, operation and maintenance tasks, and long-range financial planning. Each utility is responsible for making sure that its system stays in good working order, regardless of the age of its components or the availability of additional funds. Asset management programs with good data, including asset attributes, life cycle costing, proactive operation and maintenance, and capital replacement plans based on cost benefit analysis can be the most efficient method of meeting these challenges. Asset management is the coordinated activity of an organization, in this case, a water and or wastewater utility, to realize value from its asset. More simply put, asset management is doing the right things in the right order for the right reasons to get the right results. Asset management plan must be built on the foundation of the organization's mission, values, and the level of service it strives to provide. The most successful wastewater and water providers have been the ones that established effective asset management programs. Utility asset management can be intimidating with numerous factors to consider and many pieces of the puzzle to put together. The most common question from utilities: where do we start? Many drinking water and wastewater systems across the country will need to implement new administrative systems and management tools to allow them to adapt to the increased regulatory requirements and environmental complexities they face. These new tools will allow the system to operate on a business model for long-term sustainability to help address the issues of new and stricter regulatory requirements, growing populations, increased service demands, limited water supplies, a highly variable climate, aging infrastructure, and limited state and federal funding. A successful asset management program connects the overall mission and strategic outlook to the daily execution of asset care. Establishing this line of sight from the mission to daily work orders is dependent on getting everyone on the same page and working toward the same goals. Organizational alignment needs to be both vertical, from the executive suite to the field level, and horizontal across all divisions such as purchasing, accounting, operations, and legal. To achieve both horizontal and vertical alignment, it's important to involve everyone from the executive suite to the field level in the asset management program. While the executive suite focus on overall objectives, policies, and governance, middle management and field crews put tactical initiatives into practice. When senior management clearly articulates the organization's missions and values, middle and field level staff will have something to work with. The goal of asset management can be defined as meeting a required level of service in the most cost-effective way through the creation, acquisition, operation, maintenance, rehabilitation, and disposal of assets to provide for present and future customers. A community water or wastewater utility should care about managing its assets in a cost-effective manner for several reasons. These types of assets represent a major public or private investment. Well-run infrastructure is important in economic development. Proper operation and maintenance of a utility is essential for public health and safety. Utility assets provide an essential customer service, and asset management promotes efficiency and innovation in the operation of the system. The intent of asset management is to ensure the long-term sustainability of the water or wastewater utility. By helping a utility manager make better decisions on when it is most appropriate to repair, replace, or rehabilitate particular assets, and by developing a long-term funding strategy, the utility can ensure its ability to deliver the required level of service perpetually. The intent of asset management is to ensure the long-term sustainability of the water or wastewater utility. I just read that statement. Benefits of asset management. Examples of outcomes that can be realized by utilities through asset management. Prolonging asset life and improving decisions about asset rehabilitation, repair, and replacement. Meeting consumer demands with a focus on system sustainability. Setting rates based on sound operational and financial planning. Budgeting focused on critical activities for sustained performance. Meeting service expectations and regulatory requirements. Improving responses to emergencies. Improving the security and safety of assets, as well as reducing the overall costs for both operational and capital expenditures. There are many positive benefits of asset management. Systems that fully embrace asset management principles may achieve many or all of these benefits. However, systems may receive some of these benefits just by starting asset management. The benefits of asset management include, but are not limited to, better operational decisions, improved emergency response, greater ability to plan for future repairs and replacements, increased knowledge of the location of the assets, and more efficient operations. Asset management is a scalable approach that can be used by systems of any size. Whether running a small drinking water system serving 50 customers or drinking water and wastewater systems of the largest cities, asset management means putting in place a long-term plan to sustain these systems and the services they provide. Asset management is also used in other sectors where infrastructure needs to be managed for the long term, such as in the transportation and housing sectors. Some leading communities are adopting cross-sector asset management programs where infrastructure investments are coordinated and prioritized across the different infrastructure areas. What are the elements of asset management practice? Asset management is centered on a framework of 5 core questions, which provide the foundation for many asset management best practices. What is the current state of my assets? What is my required sustainable level of service? Which assets are critical to sustain performance? What are my minimum life cycle costs? What is my best long-term funding strategy? One of the most important aspects of asset management is that it cannot be something that the utility does on the side as one of its many activities. Rather, it must be the way the utility does business. Asset management thinking must underlie every activity, every action, and every decision that the utility undertakes. Asset inventory. The first core component of asset management is the asset inventory. This component is probably the most straightforward of all. It is also arguably the most important, as it underlies all other aspects of asset management. Many asset managers of wastewater utility systems believe that this step is absolutely critical and feel that completing this component alone can greatly improve the system's management. The types of questions that the utility will ask themselves in this component are: what do I own? Where is it located? What condition is it in? What is its remaining useful life? What is its value? Each of these facets will be discussed briefly. What do I own? The most fundamental question a utility owner, manager, or operator can ask is, what assets do I have? It is absolutely critical for a utility to understand what it owns. It is pretty hard to manage something effectively if you don't know what that something consists of. Although what do I own is a seemingly straightforward question, it is not always an easy question to answer. The difficulties arise from several factors. Some of the assets are underground and can't be seen. Assets generally are put in at different times over a long period of time. Records regarding what assets have been installed may be old, incomplete, inaccurate, or missing, and staff turnover in operations and management may limit the historical knowledge of system assets. Given these difficulties, it will probably not be possible to form a complete asset inventory in the first time the system attempts to do so. It is important, however, to recognize that the system is only trying to form the best inventory it can and develop an approach to adding to or improving the database over time. To develop the initial inventory, several approaches can be used. However, the utility should be as creative as possible with other approaches to obtaining this information. What is the condition of my assets? After the assets are determined, it is important to know the condition of the assets. A condition assessment can be completed in many different ways depending on the capability and resources of the system. One of the most important factors in determining an asset's likelihood of failure is the condition of the asset. As the asset's condition deteriorates, it will become much more likely to fail. It is important, therefore, to make the best attempt possible to give the assets a reasonable condition assessment. The condition assessment should be updated over time so that criticality can be likewise be updated. Assets given a poor or fair condition rating are more likely to fail than those given an excellent or good rating. When the asset condition is combined with other factors, the utility can begin to make predictions regarding the likelihood of a given asset failing. It is critical that utilities have a clear knowledge of the condition of their assets and how they are performing. All management decisions regarding the maintenance, rehabilitation, and renewal revolve around these aspects. Not knowing the current condition or performance level of an asset may lead to the premature failure of the asset, which leaves the utility with only one option: to replace the asset, generally the most expensive option. There are many ways to assess the condition of the assets. For example, some assets can be visually assessed. Water lines can be pressure tested or leak tested. Buildings can be monitored for energy efficiency, etc. Sometimes the only suitable way to assess an asset is to compare its performance to its expected life. What is the remaining life of my asset? All assets will eventually reach the end of their useful life. Some assets will reach this point sooner than others. In addition, depending on the type of asset, it will either reach that point through amount of use or length of service. For example, A pump will wear out sooner if it is used more and will last longer if it is used less. The actual age of the pump is not as important as the amount of work the pump has done. On the other hand, pipe assets wear out based more on the length of time in the ground. If a pipe is in the ground for decades, it has considerable time to contact the soil around it and the water within it and may start to corrode. There are many additional factors that will affect how much life a given asset has. Factors such as poor installation, defective materials, poor maintenance, and corrosive environment will shorten an asset's life, while factors such as good installation practices, high quality materials, proper routine and preventive maintenance, and non-corrosive environment will tend to lengthen an asset's life. Because of these site-specific characteristics, asset life must be viewed within the local context and the particular conditions of that utility. Cast iron pipe may last 100 years at one facility and 30 years at another. It is best to make judgments of asset life based on past experience, system knowledge, existing and future conditions, prior and future operation and maintenance, and similar factors in determining useful life. In the absence of any better information, a system can use standard default values as a starting point. However, over time, the system should use its own experiences to refine the useful lives. Generally, when utilities consider the value of assets, they think about the cost of initially installing the assets. This cost has no other importance than historical information, or it can be used by a system that depreciates the cost of assets over time. However, the installation cost does not have a direct bearing on what it will cost to replace that asset when it has reached the end of its useful life. The asset may not be replaced by the same type of asset. For example, cast iron may be replaced by PVC, or it may be replaced by a different technology entirely. A chlorination system could be replaced by an ultraviolet disinfection system. Furthermore, costs of various assets may change drastically over time, such that the cost of installing pipe in 1956 in no way reflects the cost of installing pipe 50 years later or 60 years later. Some prices may increase, such as materials, while technological advances may decrease other costs. The real value of the assets is the cost it would be to replace the assets using the technology the system would employ to replace them. If the system has asbestos cement pipe now, but would replace the system with PVC pipe, the real value of the asset is the cost of replacement using PVC and the installation cost associated with PVC. Although the idea behind an asset value is relatively simple, obtaining costs for the asset replacement is not as easy. Small utilities may not have the expertise to estimate replacement costs. In these cases, the utility should either estimate in the best manner possible or leave this portion of the inventory blank for the initial stages of the asset management strategy. It is critical for systems to understand that they do not need to worry about the data quality initially. The most important step is to develop at least a rudimentary asset inventory. The data quality can be increased over time as the system gathers more information and becomes more comfortable with the concept of asset management. Systems should also be careful to not let themselves get bogged down in this step. This step is important, but it should not be all consuming. The system should complete this step to the extent possible and then move on to the other steps. Asset age. The asset's age can be a factor in determining likelihood of failure, but should not be a sole factor. Over time, assets deteriorate either from use or from physical conditions such as interactions with water or soil, and are more likely to fail. There is no magic age at which an asset can be expected to fail. An asset's useful life is highly related to the conditions of use, the amount of maintenance, the original construction techniques, and the type of material it is constructed out of. A piece of ductile iron or cast iron may last 100 years in one application, 150 years in another, and 50 years in yet another. Rather than being a sole predictor of likelihood of failure, age should be supplemental to other information. For example, giving the same set of factors, poor condition rating, 3 failures in the past 5 years, poor construction techniques for 2 different ages, 5 years and 50 years old, the asset that is 50 years old would probably be given a higher likelihood of failure than the one that is 5 years old. It's important to monitor when assets fail and record the type of failure that occurred. This information should be as specific as possible to assist the system in understanding its failure modes. Systems should track when the asset failed, or at least when the failure was discovered, how the failure was determined, the type of failure, specific location of the failure, and any field observations that may help explain the failure. Systems should track failure history on all of the asset categories. Past failure is not a complete predictor of future failure, but it can provide some indication of the likelihood of future failure, especially if detailed information on the failures is collected and reviewed. If the asset failed because its construction was poor or the pipe was severely corroded, it is likely to fail again unless some action was taken to correct the problem. If the asset failed, however, because a construction crew ruptured the pipe, it is not likely to fail again if this is the only failure the pipe had once construction in the area is completed. Risk management. Risk management is central to all aspects of an asset management program. First, identify risk before managing and mitigating it. In effective asset management, leaders should be making risk-based decisions to balance competing demands for maintaining performance, increasing efficiency, and avoiding risk. The ultimate aim of an asset management program is to revise the risk profile of the utility for improved sustainability and resiliency. Simply put, risk is the likelihood that something will go off plan and undermine the level of service provided. It's important to define the level of service and how to achieve it. Considerations at this stage include safety for both to staff and the public, environmental responsibility, meeting regulatory obligations as cost effectively as reasonably possible, and doing so in a way that reflects the expectations and values of the community served. A criticality analysis can help identify critical systems and assets and assess the risks associated with them. This information is essential in deciding whether some assets or system require capital investment, heightened monitoring, or attention to mitigate risk. Accurately identifying and understanding criticality and risk is foundational to the success of an asset management program and securing the level of service desired. Not to mention, completing a criticality analysis with a cross-functional team can be highly beneficial for reinforcing alignment across your organization. Maximum value from assets. Getting the maximum value from assets is really about applying the best asset strategies to balance cost, risk, and performance to extend asset life and maintain service delivery. Following a criticality analysis, asset managers will have a clear set of priorities for where to target resources for activities like condition assessment, continuous monitoring, and preventive maintenance optimization. To extract maximum value from the assets, it is important to measure success and outcomes as well. Some helpful metrics to start with include the ratio of cost to repair an asset versus purchasing a new one, minimum performance targets, appropriate monitoring of critical and expensive to repair assets, and avoiding consequential failures. It is also very important to maintain whole lifecycle management outlook to effectively manage the total cost of ownership. To make decisions on where to spend money in the immediate term, it is important to understand critical assets and risks clearly. This understanding allows one to decide what can be deferred or ignored to sharpen focus and produce to significantly improve outcomes. Leadership buy-in is key to success. If there is one clear predictor for the ultimate success of asset management programs, it is leadership. When senior leadership is directly involved in supporting the asset management effort, the programs endure and achieve better outcomes. Without executive sponsorship, the effort tends to flounder and lose momentum. I recently spoke with a head engineer at a municipal wastewater department who told me, who said, my motivation for building a better asset management system is to get our staff to focus on what's important in our facilities to keep costs under control and avoid surprises. This engineer perfectly summed up the foundation for building an asset management program. Get everyone on the same page, understand the risk, get maximum value, and exercise leadership to support the effort. It's important for us to discuss briefly some things that asset management is not. Asset management is not solely software. Software is just a tool to support an overall asset management strategy and program. Asset management software is only going to be as effective as the asset management plan it supports. This is one of the reasons so many implementations fail or fail to deliver expected results. Asset management is also not a maintenance plan or a better maintenance plan. Maintenance is just one part of the asset's life cycle. Asset management is a coordinated set of business practices that covers the whole life cycle of an asset from design to acquisition through operation and maintenance to disposition. Asset management is a strategic discipline that includes the tactical efforts of managing assets such as maintenance. Next, asset management is not a condition assessment. Too often when a water or wastewater utility talks about their asset management plan, what they are really describing is their condition assessment plan for their network. Condition assessments are vitally important and deliver an excellent return. But again, they're just one part of the big picture of asset management. Implementing an asset management program will deliver positive results for a utility. Managers and administrators will be able to make better decisions for better outcomes. Simply by completing a criticality analysis will allow them to make adjustments to O&M plans for almost immediate returns. In conclusion, protecting water quality through adequate wastewater treatment is critical to maintaining economic vitality and quality of life. The concept of asset management should provide the tools needed by wastewater systems to actively and consistently analyze current operations and future needs in order to develop robust management systems and well-designed infrastructure to meet the growing challenges of the future. I'd like to thank you for allowing me this opportunity to speak to you today. And at this time, Christy, I'm going to turn it back over to you.
Thank you, KT. And it appears, right, everyone, I'm sorry about that. It seems like maybe KT is having some connectivity issues. But thank you all for attending. Following this webinar, each of you will receive a follow-up email with the slides from today and a link to the recording. We ask that you please complete the webinar evaluation following this webinar so you can let us know your thoughts on today's session. This helps us plan future webinars that are on topics that are important to you. Thank you all again for attending, and we hope to see you at future EFCN events.